Hello everyone, welcome back to the channel. Today I am going to explain the difference between current and voltage in the simplest way possible. This is one topic that confuses almost everyone in the beginning. Many people think that if the voltage is the same, then everything should work the same, but that's not true. In this video I will explain this practically. I have two transformers here. Both transformers give 12 volt AC, but they have different current ratings. I will convert this AC into DC using a full wave rectifier circuit and a voltage regulator with an output of 12 volt DC. And then I will test the output using a 12 volt DC lamp and a 12 volt fan. By the end of this video, you will clearly understand the real difference between current and voltage. First, let's understand the basics in very simple words. Voltage is like a pressure. It is the force that pushes electric charges through a wire. You can imagine voltage like a water pressure in a pipe. If the pressure is high, water is pushed strongly. Current is the amount of charge that actually flows. It's like the amount of water flowing inside the pipe. So remember this, voltage pushes and current flows. Now let's come to the practical part. Here I have two transformers. The first one is a small transformer rated at 12 volt AC but with low current capacity. The second one is a bigger transformer, also rated at 12 volt AC but with a higher current capacity. The second one is a bigger transformer, also rated at 12 volt AC but with a higher current capacity. The voltage is the same in both transformers, but the current is different. I'm not going to use AC directly. I built a full wave rectifier circuit using a diodes, a filter capacitor, a regulator IC, LED and a 1K resistor to get a stable 12 volt DC. This circuit converts the 12 volt AC into DC. After rectification, we can get around 12 volt DC at the output, which is perfect for our test. First, I connect the small transformer to the rectifier circuit. Now I connect a 12 volt DC fan. You can see that the fan turns on because it requires a small current to operate. Now I connect the 12 volt DC lamp. The lamp does not turn on. You can see that the lamp does not turn on because it requires a larger current to operate. This happens even though the voltage is similar. Now I disconnect the small transformer and connect the bigger transformer. Again, the voltage is still 12 volt DC. Nothing has changed in the voltage. Now I connect the same 12 voltage fan and you can see that it turns very fast. When I connect the same 12 volt DC lamp, it glows very brightly. So what changed here? The voltage is the same, the rectifier is the same, the load is the same. The only difference is the current capacity. This is the most important concept you must remember. Voltage is given by the source, but current is taken by the load. The lamp and the fan draw the current they need. If the power supply or a transformer can provide that current, the device works properly. If it cannot provide enough current, the voltage drops and the device does not work correctly. So having the same voltage does not mean the same power. Current decides how much power is actually delivered to the load. That's why a small transformer cannot run a fan, even if the voltage rating is correct. Or that's why a small transformer cannot turn on a DC lamp, even if the voltage rating is correct. Think of it like a water flow. You can have the same water pressure, but if the pipe is thin, only a small amount of water can flow. If the pipe is thick, more water can flow at the same pressure. Voltage is like a pressure and current is like a flow. So to summarize this video, voltage is the pushing force and current is the flow. The same voltage with low current gives a weak output, and the same voltage with a high current gives a strong output. If this video helped you understand the difference between current and voltage, please like the video, share it, and subscribe to the channel. If you want more practical videos like this, let me know in the comments. Thanks for watching.